So this question is question 6 from the May 2009 exam, paper 2. So this question involves a geometric series, and part A requires us to find the value of r. Because we're given the values, this part is fairly simple. We can use the equation un equals u1 times rn minus 1. We know that u4 equals 1 over 3, and u1 equals 1 over 81, so we can sub those into the equation to get 1 over 3 equals 1 over 81 times r to the power of 3, which we simplified from 4 minus 1. Then simply we can isolate r to the power of 3 by multiplying both sides by 81, so we can get 27 equals r to the power of 3, and therefore r equals positive 3. Because for r equals negative 3, we would have gotten an answer of negative 27. Now, part B asks us to find the smallest value of n for which Sn, which is the sum of the terms in a sequence, is greater than 40. So, we can just sub in 40 for Sn and then round up to find the whole value for n. We can just use the geometric series sum equation for this. So we get Sn equals u1 times rn minus 1 over r minus 1. We sub in our values, so 40 equals 1 over 81, which is u1, times 3, which is r, n minus 1 over 3 minus 1. Now we're just going to try to isolate 3n, 3 to the power of n. So we can multiply both sides by 2 to get rid of the denominator on the right side. So we can get 80 on the left side, and then we try to get rid of the 81 on the right, 1 over 81 on the right side by multiplying both sides by 81. And then we're left with 3n minus 1 on the right side, so we can add 1 to both sides. So we can get 6,481 equals 3 to the power of n, and because we have an unknown exponent, we can just use our log laws and try to isolate n, so we get log 6,481 equals n log 3, divide both sides by log 3, so we get n equals log 6,481 over log 3. So a fairly exact answer is 7.98 equals n, and because we are trying to find the smallest value of n for which Sn is greater than 40, we can round that up to 8.